In this video, we're going to apply the substitution method to solve a few more integrals. Here we have integral tan x times log of cos x integrated with respect to x. We're going to let u be equal to log of cos x. The differential du is going to be, let's take the derivative of log of cos x, that's 1 over the inside, 1 over cos x, and multiply by the derivative of the inside, derivative of cos x is negative sin x. We have applied the chain rule here, times dx. If we simplify this, we get du is equal to minus sin x over cos x, that's just tan x dx. The minus comes out, we get minus du is tan x dx. So we have integral log of cos x times tan x dx. We have rewritten the integrand in such a way to make the substitution easier to see. So log of cos x, that's just going to be u. Tan x dx, this part is minus du. So we have integral minus u du. And integrating minus u with respect to u is going to be minus u squared over 2, reversing the power rule, plus c. Now substitute u back in, and we get minus 1/2 log of cos x all squared plus c. This is the antiderivative. So we have shown that the integral tan x times log of cos x times dx is equal to negative 1/2 times log of cos x all squared plus c. And if you were to differentiate this part, if you were to differentiate the answer, you will get that integrand back. That might be a good exercise to do. All right, the next question is looking at the definite integral from 0 to a, x root of x squared plus a squared, integrated with respect to x. We're going to let u be the inside function as usual, so we'll let u is equal to x squared plus a squared. The derivative du is going to be 2x plus derivative of a squared is going to be 0 because a squared is a constant. It doesn't change with respect to x. So it's going to be 2x plus 0 times dx. Let's simplify. Du is 2x dx. Now we're going to have to transform the limits. So let's change the x limits to the u limits. X equals 0, the lower x limit, gets plugged into u is equal to x squared plus a squared. Plugging x equals 0 in, and we're going to get u is equal to a squared. X is equal to a, that's the upper x limit. Plug that into u. U is equal to x squared plus a squared. We get u is equal to a squared plus a squared is 2a squared. All right, so now let's rewrite the integral. We have integral 0 to a root x squared plus a squared times x dx. Now, root x squared plus a squared, this part is going to be root u. X dx is going to be 1/2 du. Let's show that here. We can divide by both sides, and we get 1/2 du is equal to x dx. So what we have is, and we also transform the limits, so we have the lower u limit as a squared, the upper u limit as 2a squared, u to the 1/2 times 1/2 du. 1/2 is a constant, passes through the integral, and we get 1/2 integral from a squared to 2a squared u squared du. So we get 1/2, reversing the power rule. This should be u to the 1/2. So u to the 1/2 du. Reversing the power rule, we're going to get u to the 3/2, adding 1 to the exponent. 1/2 plus 1 is 3/2. Divided by 3/2 is equivalent to multiplying by 2/3. And evaluated from a squared to 2a squared. Let's simplify a little bit. This 2 cancels with this 2. We get 1/3 u to the 3/2. Evaluated from a squared to 2a squared, we're going to apply the fundamental theorem of calculus. We're going to get 1/3 times 2a squared to the power of 3/2 minus a squared to the power of 3/2. All right, we're going to need to do some simplification here. So we get 1/3 times 2 to the 3/2 times a squared to the 3/2 minus a squared to the power of 3/2. Alright, this 2 cancels with this 2. We get 1/3 times 2 to the 3/2 times a cubed minus this 2 cancels with this 2 minus a cubed. Let's simplify a little bit more. Factor out the a cubed. We get a cubed over 3 times 2 to the 3/2 minus 1. So what we have shown is the integral from 0 to a, x root of x squared plus a squared, integrated with respect to x. The value of this definite integral is a cubed over 3 times 2 to the 3/2 minus 1. Alright, let's look at another question. Here we have integral sine of pi over x divided by x squared integrated with respect to x. We're going to let u be equal to the inside function as usual. U is pi over x. Du is equal to minus pi over x squared dx. I've applied a shortcut here, so let's show that. We have d dx of c over x. We can rewrite this as d dx of c x to the minus 1. Now applying the power rule, we get minus c x to the minus 2. That's equal to minus c divided by x squared. That is d dx of c over x. It's better to memorize this. That way you don't have to go through the whole process of the differentiation process, and you can just apply that directly. Alright, let's divide by negative pi, and we get negative 1 over pi du is equal to 1 over x squared dx. So we have integral sine of pi over x times 1 over x squared dx. Sine of pi over x, this part is just going to be sine of u. And 1 over x squared dx, this part is negative 1 over pi du. So we have integral negative 1 over pi sine u du. Negative 1 over pi is a constant, passes through the integral, and we get negative 1 over pi integral sine u du. Now antiderivative of sine is going to be minus cos, so we get negative 1 over pi times minus cosine u plus c. Minus times minus is plus, so we get 1 over pi cosine u plus c. Now let's plug u back in. We get 1 over pi cos of pi over x plus c. This is the antiderivative. This is the answer to this integral. All right, thanks.